Hi, I'm Alejandro Suarez, and with me I have Anya Silvestre and Tyler Grinault, and we're going to talk to you about our proposal for predicting epidemics. So, to introduce the proposal, I'd like to show you guys a quote by Trust for America's Health, which kind of gives us some insight that influenced us for the proposal. And it really brings up things like how basically not all diseases that we're finding today are just new diseases like Zika. Well, I mean, sure, some of them are, but we also have viruses and diseases that have adapted to our current medicines and have created other illnesses. For example, we have like the flu, which has evolved due to medications and things like that to the swine flu. So now it's something different. And that is something that's happening every day. It's something that will continue to happen. And that's basically the thinking behind what gave us our idea for our proposal. So going from that general to something more specific, here's the basic problem behind what our proposal is about. So basically diseases and viruses, they all infect other people. And you have, as seen in the image, you have things like hepatitis C that can infect up to around two or three people, whereas you have something big and powerful like measles that can infect up to 18. And each of these diseases and viruses can infect one person, which can then infect another 18 or however many that it can spread to. And it can just increase exponentially, which can be a huge problem for society today if there were to be a big epidemic or a plague. So going off of that, let's go to the problem. Okay, so the basic problem we face is how do geographical barriers impact the spread and development of pathogens? So as seen in the image there, the three big factors that we thought that really make up for what is the perfect storm for a disease is the host, the pathogen, and the environment. Host being the humans in our case, and pathogen being the disease or virus or whatever illness we're testing. And the environment is basically what we're testing to see how it can be affected by certain conditions like climate and humidity, altitude, all those kinds of environmental conditions. So going off of that, Tyler will continue.
All right, thank you, Alejandro. Cool. So we're going to go ahead and talk about some of the background information dealing with this research proposal. Looking at a couple of scholarly journals, Parasitology and PLOS ONE. In one experiment, it was seen that there's a direct relationship between the effectiveness of a pathogen spread and the climate in which it is harbored. From the journal PLOS ONE, in an experiment, it was seen that a geographical barrier such as a river, mountain ranges, or a general climate affect the migratory patterns of the parasitic chromosome. And then for future reference and the type of cell we determined that was the best to test in being MRC5 cells, those are cells that are obtained by fetuses and are most commonly used in the production of vaccines. All right, so now as to the purpose of this study, well, we decided that we're going to test the survivability of pathogens and its spread by testing each in conditions mimicking various climates found around the world. Determining areas of the world at risk for pathogen spread and to which pathogens they are at risk to. All right, moving on to our research question. Based off of all the background study we did, our research question is it possible to predict which geographical areas and those individuals living in them are prone to an epidemic before it occurs? Cool. And then down there we have a little figure showing the spread of this disease. And our hypothesis based off of that research question and all the background work that we came up with is if infected MRC5 cells continue to infect healthy MRC5 cells while exposed to different climate conditions, then we can map a future outbreak in that area before it has even started. Cool. Looking at some of the methodology behind that research proposal and the hypothesis we have developed, we're going to infect MRC5 cells with an arranging pathogens and harbor each and test in various climate conditions. In those climate conditions, we hope to test things such as different temperatures found around the world, different humidity levels, different levels of oxygen that range in altitudes the pathogen would be found in. We're wanting to do this because that will give us a true representation on how that pathogen is able to spread in these areas. Based off of this knowledge, we can map the predicted course of pathogen spread and the development through a region based off of those test conditions. And as well, we want to monitor the rate of growth by using flow cytometry, by counting those amount of healthy cells and different infected cells. Cool. So I'm going to go ahead and bring up Anya. She's going to talk about the roles and responsibilities of the researcher.
Okay. So as our responsibilities for the roles and responsibilities of us, I found a really specific type of policy that the University of Texas at San Antonio actually gives us, and that is the UTSA's Institutional Biosafety Committee policy, and that's IBC. So as researchers, it's our duty to make these new discoveries and make modifications to other discoveries, but also to regard ethics and morality in the research place. So this means adhering to the specific ethical guidelines as provided by, like I said, the IBC. So as we go throughout our experiment, at least our hypothesis one, we have to adhere to specific ethical principles. So obviously we cannot put out this pathogen out into, say, a mountain range just to test it out, because it's completely immoral, it's completely illegal to test it out on humans, animals, or anything that can harm the environment that is actually specifically stated within the IBC. So, but in our regular proposal, it is ethical to, or really appropriate to have it in a petri dish and just kind of make our own little simulation, as long as it is inside the institutional facility that UTSA gives us. Okay. And basically the proper training and personnel of handling of this hazardous material is to just burn it. You can't throw it away or anything like that, because even if you contain the virus, it could probably spread to other items that is in the trash or whatnot. But really the only way to dispose of these pathogens is to burn them, to make sure that they don't contaminate anything or affect anything that comes in their way. Okay, so the impacts and implications of the research, and basically it's to educate the government and how to handle certain disease spreads. And obviously our goal here is to eliminate epidemics more really, and if we could figure out how to prevent them from spreading because of geological barriers, that means that we could be able to map out a disease, and this is in the future speaking. And we could also influence future experiments about the predictions of other epidemics, so that we can somehow, like I said, map them, track them, and just in general eliminate them from the world. Questions?
I think we're done. Thank you. We hope you feel better, Dr. M.
Get well soon, Dr. M.
Get well soon, Dr. M.
Thank you. All right.
She's going to be like, that was not part of it.